Assalamu alaikum. Today on 5th November 2025, I'm starting lecture number 1 for week number 9, and the topic of today's lecture is vector equation of a line. So what is vector equation of a line? Actually, we can write the equation of a vector, uh, sorry, equation of a line in vector form using the standard equation R, vector R equals to vector A plus T into vector P. Okay, so what is it? Actually, R is the position vector of line, while A is the given point, that is a point that through the line is passing. P is the direction vector of the line and T is the parameter T. So what happens that if we know one point through which the line is passing, for example, the point is 1, comma 2, comma 3. Suppose this is the point P1 through which the line is passing, and we know that the direction vector of the line is -1, 2, and 4. Suppose this is the direction vector of the line. Then how can we find the parametric equation of the line? We will simply use this vector equation, R equals to A plus TP. So we will write R is equals to A, vector A plus parameter T times vector P. So in place of R, we will put the X, Y, and Z variables. In place of A, we will put the point 1, 2, 3 through which the line is passing. While in place of the direction vector, we will write -1, 2, and 4. So hence the vector equation R equals to A plus TP basically gives us a format where we can write three parametric equations for this straight line. So the first parametric equation is x equals to 1 plus -1 times t. That is x equals to 1 minus the parameter t. Similarly for y, we can write y equals to 2 plus 2t. And similarly for z, we can write z equals to 3 plus 4t. So these are the three parametric equations that we can write for this straight line. Okay. So uh, in short, uh, in vector analysis, in vector algebra, we don't write the Cartesian equation of the straight line. Rather, we write the vector equation of the straight line. And what is the generic equation? The generic equation is position vector R is equals to position vector A plus T times the direction vector of line. Now, if the direction vector is given, and if we know one point through which the line is passing, we can easily write the vector equation of the straight line. Now, this vector equation basically gives us three parametric equations x, y, and z. What are parametric equations? If x, y, and z are related to each other by a third variable t, then this third variable t is the parameter. And the equations that are relating x, y, and z are known as parametric equations. Okay, so this is the simplest and easiest possible way that we can write the vector equation of a straight line, and then we can deduce the parametric equations. Okay, but sometimes what will happen that they will provide you 2 points. Suppose one point is P1 And suppose this point is -1, 3, 9. And then they will give you another point P2. And suppose this point is 4, 3, and -5. Okay. Now what they will do, they will ask you to write the vector equation of the straight line. So first of all, if we are given 2 points, first of all, we will find the direction vector P. So the direction vector P will be the vector P1, P2. Okay. Now how we will find P1, P2? It will be OP2 minus OP1. That is, we will subtract OP1 from OP2. So first of all, we will write OP2. It is 4, 3, -5. And then we will subtract OP1 from it. That is -1, 3, and 9. So what will happen? It will become 4 plus 1, then 3 minus 3, then -5 minus 9. So finally, the direction vector P obtained will be 4 plus 1, 5, 3 minus 3, 0, and -5 minus 9 minus 14. So when we have solved for the direction vector P, we can easily calculate the vector equation using the generic equation R equals to A plus TP. And again, in place of R, we will write X, Y, and Z. And in place of A, we can write any of the 2 points, P1 or P2. So suppose we are using P1. So in place of A, we will write -1, 3, and 9. In place of T, we will write T, since it is a variable, which is a parametric variable, T. And then in place of P, we will write the direction vector, that is 5, 0, -14. So this is basically another way to find the vector equation of a straight line. If we are given 2 points, P1 and P2, first of all, we will calculate the direction vector. Then after calculating the direction vector, we will again use the vector equation of straight line, that is R equals to A plus TP, where R is the position vector X, Y, and Z. A is any point through which the line is passing, and P is the direction vector. So using this parametric, this vector equation, we can always find the parametric equations of the straight line like we have done before here. So this is how we calculate the vector equation of a straight line. Okay. Now let us just open our book, and you can see in exercise 12.5, they are saying find the parametric equation for the lines through question number 1 to 12. So what is happening there? In question number 1, they have given you that the point is that the point is 3, -4, and -1, and we need to calculate the parametric equations while the direction vector is I, J, and K. Okay, so let us solve this question. Exercise 12.5. Question number 1. The point given is P, whose coordinates are 3, -4, and -1. And this line is parallel to a vector I plus j plus k. Okay. So how can we solve this equation? How can we find the parametric equations? It's very simple. First of all, we will write the vector equation of the straight line, that is vector r equals to vector e plus parameter t times the direction vector p. Now vector r is the position vector x, y, z. Point vector A is basically the point through which the line is passing. So since the line is passing through 3, -4 and -1, so in place of vector r, we will write 3, -4 and -1. In place of t, we will write t. And in place of p, that is the direction vector, we will write the vector ijk. Now ijk means 1 in the direction of x-axis, 1 in the direction of y-axis, and 1 in the direction of z-axis. So hence the direction vector is 1, 1, 1. So now we can write x, y, and z equals to 3 plus t minus 4 plus t and -1 plus t. So now we can easily deduce the uh, parametric equations. The first parametric equation is x equals to 3 plus t. The second parametric equation is y equals to -4 plus t. And similarly, the third parametric equation is z equals to -1 plus t. So in short, whenever we will be given one point and a direction vector, that is the direction vector of the given line, we can always find the vector equation using this general equation r equals to a plus tp. And once we have written the vector equation, we can always deduce the parametric equations from the vector equation. Now, this is the first parametric equation. This is the second parametric equation, and this is basically the third parametric equation. So how can we find the parametric equation? Simply by comparing x to x, y to y, and z to z. Okay, so uh, this is how we write equation of a straight line using vector analysis. We can always write equation of straight line using Cartesian equations, but since this is a chapter related to vectors, so here we are basically learning how to write vector equation of a straight line and how to deduce parametric equations from that vector equation. Okay, so that was question number one, and from question number one till question number 12, I guess everything is basically about to calculate the vector equation and the parametric equations. Like in question number 5, they are saying the line through the origin parallel to the vector 2j plus k. So it's uh, just as question number 1, because we are given a direction vector which is 2, 0, and 1. Sorry, 0, 2, and 1. Why? Because there is no I. So the direction vector along I is 0. Similarly, the direction vector parallel to y-axis is 2, and the direction vector parallel to z-axis is 1. So its direction vector is basically 0, 2, and 1, and the given point is basically origin, that is 0, 0, 0. So again, we can easily solve this question. So students, if you want me to solve any question from 1 to 12, 1 to 9, you can always tell me, okay? So which question should I solve for you from 1 to 9? Okay, I think since it is the first day right after the midterm exam, so students are quite tight. So let me solve one question for you. Okay, if we are to solve question number 6, They are saying the line through the point this parallel to the line x equals to 1 plus 2t, y equals to 2 minus t, and z equals to 3t. So let us solve question number 6. In question number 6, we are given a point which is 3, comma, minus 2, comma, 1. And then they have given us uh, basically parametric equations of another line, which is x equals to 1 plus 2t, comma, y equals to 2 minus t, and z equals to 3t. So we are to find the equation of the line that is passing through the point 3 minus 2, 1, and which is parallel to a line whose parametric equations are given. Okay, coming back to our camera. So this is the situation. We know the point through which our line is passing, but we don't know the direction vector of the line. But they are saying that the line should be parallel to the line whose parametric equations are this. So from these parametric equations, we will deduce the vector equation of the given line. So the vector equation of the given line would be 1, 2, 0 plus t times 2 minus 1, 3. So you can see that I took 1, 2, and 0 as the point from where the given line is passing, and the coefficients of the parameter t are basically serving as the direction vector of the given line. Okay, so the given line has the direction vector p, which is equals to 2, minus 1, and 3. So now what we need to do, we know that our line is passing through the point 3, minus 2, 1, and we know that our line is parallel to this given line, which has a direction vector 2, minus 1, and 3. So quite easily now we can find the vector equation of our line. So vector equation of our line would be x, y, z. In place of a, we will write our point, which is 3, minus 2, and 1. And since our line is parallel to this line, so their direction vectors must be equal. So in place of the direction vector p, we will write the direction vector of the given line. Why? Because the given line was parallel to our line. And if two lines are parallel, their direction vectors must be equal. Okay. So hence we deduce that the parametric equations are x equals to 3 plus 2t, y equals to minus 2 minus t, and z equals to 1 plus 3t. So that is how we can find the vector equation of our line in question number 6. Let me just add those people that need basically some verification. So although I have added all of you in our class, so if you join through your class, you won't be needing this verification. But still, some students are basically joining using the passcode and the I think other thing. Never mind. So students, what we learned in this question, that if you are given the parametric equation of another line and a point where your line is passing, then to find the direction vector of your line, you need some information. So they told us that the given line is parallel to the required line. So if the given line is parallel to the required line, then the direction vectors of the line given and the line required must be equal. So first of all, using the given parametric equations of the given line, we identified that the direction vector of given line is 2, -1, and 3. And since now we know that our line, which is the required line, is parallel to the given line, so therefore the direction vector of our line would be the direction vector of the given line. Now finally, we used the vector equation r equals to a plus tp, which basically tells us that the vector equation of any straight line is the position vector r, which is xyz, times, equal to direction vector a is basically the point through which the line is passing. So since our line was passing through 3, -2, and 1, so in place of vector a, we wrote 3, -2, and 1. Similarly, in place of t, which is parameter, we will write parameter. And in place of p, we will write the direction vector, which we identified as 2, -1, and 3. Okay, now let me tell you some theory regarding the point of intersection of two straight lines. Okay, so how we will find the point of intersection of two straight lines? So for that thing, what we will do, we need to have two vector equations, and then we will find the point of intersection of the two lines. Okay, so let me just find quickly one question that is related to this thing. Okay, so if you can see question number 53, here they are saying that find the point in which the lines meet the plane, or find the point of intersection. Okay, so in question number 53, we have been given with the parametric equation of a straight line, and 2x minus y plus 3z equals to 6, which is equation of a plane. And then they want us to calculate point of intersection. Okay, so how we will find the point of intersection? It's very simple. First of all, let me just write the question on my register. So the given equation of straight line is basically x equals to 1 minus t, y equals to 3t, and z equals to 1 plus t. And the equation of the plane is 2x minus y plus 3z equals to 6. This is basically question number 53. And here we are learning how to find the point of intersection of a straight line and a plane. Okay. So this is uh, the representation of straight line in parametric equations. A straight line can be written in the form of parametric equations, where uh, the parameter is basically t here. Why? Because x, y, and z are related to each other with the help of a fourth variable, which is t. So this fourth variable is the parameter, and these three equations are basically the parametric equations. Okay, now we need to find the point of intersection of this straight line with the point of intersection with this plane 2x minus y plus 3z equals to 6. So it is a very simple thing. How can we do that? We will basically put the values of x, y, and z in terms of t to equation number 2. So what we can do, in place of x, we can write 1 minus t. Similarly, in place of y, we can write 3t. And in place of z, we can write 1 plus t. So what we have done, we basically replaced x, y, and z with their parametric equations, which were basically given by the straight line. Now we will find t. So 2 into 1, 2. 2 into minus t, minus 2t. Minus 3t plus 3 plus 3t equals to 6. Okay. Now 3t and minus 3t are cancelling each other. So it will become 2 plus 3, 5 minus 2t equals to 6. Now we will move this 5 to the right hand side. So minus 2t equals to 6 minus 5. So minus 2t equals to 1 and t equals to 1 upon minus 2. So finally our t is minus 1 over 2. So once we have calculated the parameter t, we can easily find the point of intersection using the parametric equations. So our x is 1 minus t, which is basically 1 minus 1 by 2. So which is 1 plus 1 by 2, which is 3 by 2. Similarly, our y is 3 times parameter t. So it is 3 times minus 1 by 2. So it is minus 3 by 2. Similarly, our z is 1 plus t. So it is 1 plus minus 1 upon 2, which is equals to 1 minus 1 upon 2, which is 1 upon 2. Okay. So finally, the point of intersection is 3 by 2, comma, minus 3 by 2, comma, 1 upon 2. So this is how we find the point of intersection of a plane and a line. Since we have been given with the parametric equations of the line, using those parametric equations, in equation number 2, we found the parameter t, which was t equals to minus 1 by 2. Now using t equals to minus 1 by 2, we can calculate the values of x, y, and z using the parametric equations x equals to 1 minus t, y equals to 3t, and z equals to 1 plus t. So hence we found out the point of intersection of a straight line and a plane. So students, since it is the very first lecture after the midterm exam, and I realized that you people are quite tired due to your consecutive papers. So we keep it brief today, and inshallah, we will discuss more uh, exercise problems in the coming on-campus lecture. So if you have any question, you can ask it right now. Okay, no questions. So inshallah, we'll meet you in the next class. Till then, take care and Allah Hafiz. First of all, we will stop the recording and then we will take the attendance. Allah Hafiz.